Hello and welcome to the Superposition Guys podcast. My name is Yuval, and my guest today is Elham Kashefi, Chief Scientist of the UK National Quantum Computing Centre. Elham and I discuss the history and future of this national strategy, the new Quantum Solutions Lab, quantum-inspired algorithms, what blind quantum computing is, and much more. We hope you enjoyed this episode. Hello, Elham, and thank you for joining me today.
Hi, thanks for having me, Ivan.
So who are you and what do you do?
I'm Elham Kashefi, a professor of quantum computing at University of Edinburgh, superposed with being the director of research of CNRS at Sorbonne University. And I look at quantum computing from a computer science background and a bit of math background. And I like to make sense out of it in any sense, in any way I can.
And I think you're now involved deeply, I would say, with the UK National Quantum Program. Is that correct?
That is correct. I've been there from the birth.
What do you do for them?
So the history goes is like the national program. Well, my education started in UK. Maybe I start saying that, So I did my PhD back in Imperial College, then Oxford University, then University of Edinburgh. But meanwhile, I have been always, have this French part of my life that we come and talk about that as well at CNRS. But particularly about the national program, when it was announced almost a decade ago, I was involved first in the first phase of the hub, NKIT, UK Quantum Technology Hub. I was associate director in charge of application. Then it come the second phase. I was the member of the senior science team, again in charge of software and application. So you can see all the time I have been trying to be the connector between our colleague from physics, engineering, computer science, math, and trying to focus on application. And very recently, in November, I was elected as Chief Scientist of NQCC, National Quantum Computing Centre. And again, trying to push algorithm and software activity and trying to make sure we have a co-developed program between hardware and software.
When people think about algorithm and software, they usually think about computing. Is the National Quantum Program broader than that? Does it also cover sensing or communications or other things?
Yeah, definitely. So when the National Quantum Technology Program was announced, prior to many other national programs was announced, is actually set the agenda that we have quantum sensing. So that was one of the hub led by Birmingham, many other universities. Then there was quantum imaging and metrology led by Glasgow. And then quantum computing and simulation hub led by Oxford that we were just talking about, and quantum communication led by York. So indeed, the UK from the very beginning have this sort of four pillar that we saw it repeated almost in many other programs. But the national program is covering it all. But the NQCC, which was only recently in 2019 was announced, is a dedicated center for the quantum computing aspect. But the national program and future program, which is just again announced 2.5 billion by UK government, it goes for all the technology, the full spectrum.
You mentioned other national quantum programs, and there seem to be many of them. Is there something that's unique about the UK program from your perspective in terms of the goals or other aspects?
If I want to do the proper verification benchmarking, and then I need to first sit down and do my homework and study all the other national programs, which I haven't done. So I'm a bit familiar with the EU flagship. I've been a part of it, so I can keep that in mind. And I hear here and there from the other programs. So I would not be able to really say so unique. I would say in UK started very early on. So that's something unique in terms of, they started, it was 10 years ago. So it's a decade ago. And many other places, they also have this sort of dedicated quantum program, DARPA, we heard about it and all these things. So, but I think UK was very early on try to put this perspective, okay, quantum science has been going down and they have been supported for a long time, and they wanted to start this program of the translation, this transition to making sure the science that has been expanded in all the academic domain will be step by step going towards the technology deployment. And I would say probably because they started early on, they have done it, it's hard to say rigorously, but they have done it over the time. So it has been a very patient program, which I think I appreciated a lot. That, for example, it was very clear, quantum imaging, quantum sensing, it can come out early than quantum communication, but it was very clear. And thanks to all the policymakers and all the lobbyists and all the influencers of the national program, that they knew quantum computing is going to be a long program, and another 10 years, another 20 years. So I think this combination of what politician wants to see versus what is realistic in terms of timeline, it was something that they have done it in practice. As a result, they managed to attract a lot of talent. They managed to be early on to say this is the place. And I would say something else. Again, I don't have the numbers and all the facts in my hand, but I feel because it started 10 years ago, and not just me, many of my other academic colleagues who were part of the hub and part of this ecosystem, we have been trained through national program to become entrepreneur. I co-founded my own company, Very Cloud, that happened to be in France, but many of the colleagues that we started 10 years ago, they are now co-founder of the various quantum startups in UK or elsewhere. So I think that's also a credit to this sort of long procedure that, naturally assisted us to go through this step and create a very a promising ecosystem. I think we are second to probably US in the number of quantum startup for a nation, which is impressive. So that's another aspect of this transition that I was talking about earlier.
Having been involved both in the UK side, in CNRS on the French side, in dealing quite some time with quantum software and applications, what do you know today? What have you realized today that you didn't know 12 months ago about quantum software?
12 months ago, what do I know today that is not... so I kind of knew it already then, but let's say that I truly believe in it, that is some sort of a motto that we use a lot about our recent activity that I'll talk about in a second, that it's really take a whole village to build a quantum application. I always say I take a village to raise a child, and it takes the entire ecosystem to build a useful quantum application. So going back to your question, looking at what's happening in UK, what's happening in France, and what's happening everywhere, and you always have this academic industry, this pull and push. Today, I'm even more confident than ever that if we're really serious about useful quantum application, it's not just hardware development. We need to actually influence hardware when we're talking about application. And it's really, we need to start talking all together in the sense that who has the pain point, who has the solution, it's become even more than ever that we need to have this interconnection rather than somebody figure it out and has the killer app and off you go, they're going to build the quantum computer and, let's protect the IP sort of. This sort of interconnection, it's becoming a new thing in my own way of perception of what's happening to the ecosystem.
Speaking of new things, and I think you mentioned it in passing, there's this new quantum software lab that you're heading, right? Could you tell me about that, please?
Yes, I already spoiled it. It was like the recent baby. So we spent the last few months really launching it. So after my appointment was announced as the NQC chief scientist, so we have been developing the first physical node of NQCC, which is based in South. And now in North, in Edinburgh, we have the first physical node of NQCC, and we launched the Quantum Software Lab. The history of it goes back in Edinburgh. We have had already one of the largest quantum software team in UK with the 6 faculty, soon with the 2 new to be announced. So it was this momentum of various people with a different background come together. We have been building our village, for the last decade. And then the momentum with my appointment, with the support of NQCCs, now we have created Quantum Software Lab. 2 weeks ago, it was announced. So we signed a memorandum of agreement between NQCC and University of Edinburgh. And what I'm trying to do with the NQCC Software Lab, and we have an initial pilot project, which is called Quantum Advantage Pathfinder, is really, again, contributing to this interconnection space I was telling you. So in the UK, if I take one step back, in the UK, we have technology hub, quantum hubs, which have been pioneering the science. All the top scientists in UK, they are involved in various hubs, including quantum computing hub. They are discovering the resources. Then we have this very rich program of Innovate UK, which has already brought industry-led project with the academic and focusing a little bit on the use case discovery and application. And then we have NQCC and other national lab, which they have their own position, like NPL, the position in the National Lab for Testing, NQCC, now National Lab for Quantum Computing. So what we're trying to do with the NQCC Quantum Software Lab, and a bit of what is my role as NQCC Chief Scientist, to connect all these 3 pillars and try to really bring the science and technology and use case deployment together. So now how are we going to do that? I'll wait till you ask, but essentially is an in-between place that I have been dreaming for a long time, that is not just pure academic and is not just pure industry. We call it like we're trying to create a startup culture, but it's still within the academic, because we still need to do blue sky research, but it's much more focused to the use case delivery.
How would that work? Let's say I'm a commercial company, not in the quantum space. I've got a interesting machine learning classification problem. I'm not happy with the classical solutions, or not happy enough. I want to investigate whether quantum is the place for me. Do I come to the QSL? Is there some other path to see if the QSL can help me solve my problem?
All right, so you're already a very good, you're an ideal customer for us, because we actually set up to even help with the people who don't even know anything about quantum. So we have this pathfinding methodology that we have in mind, is that, okay, industry end user come with their pain point. They might not even know that this is actually machine learning classification. So in your case, you're ahead of the curve, but we even want to helping with the hand-holding of translating this pain point, that I want to have a better production, I want to have the cheaper data loading, etc., translate into the mathematical. So we have this use case discovery work packages that we were organizing, as well as NQCC have lots of program like a Spark and AIM Day, etc. So we're dragging those use case. We doing the translation to understand what is the mathematical problem related to this use case. And then we go through the user journey, as you were mentioning. Okay, now user journey means that I need to find what's the best algorithm, whether it's simulation, optimization, machine learning, etc., matching to that particular mathematical problem. Then it comes the question, okay, how do I benchmark? And that's the expertise of the lab, that we have a large, class of approach of benchmarking, whether it's error mitigation or verification and testing versus HPC versus classical. So we do all of this benchmarking, having access to the hardware. We have and also partnership with the AWS, but we have other partnership through NQCC. So we will benchmark. And the idea is that after this cycle of going back and forth, we will be able to answer this question, whether indeed there is an advantage in quantum, or maybe there isn't. In fact, you're stuck with your classical solution. And because we are academic and we are actually, at the end of the day, we want to publish a paper and feasibility report, we might, for many of these use cases, happily provide the negative result, but also being able to provide the real feasibility that when and how you might achieve that advantage. And maybe, who knows, but some of the particular application, for example, in security, etc., might be readily made and we can even point it out. So what I'm trying to say that we like people come to QSL because we are not a company, we're not having any product. We want to close that gap. So if it's too expensive or too soon for somebody to already talk to the particular member of this ecosystem, we would be able to help. But that again is my role, to be able to matchmaking when the problem is actually an academic problem, when the problem is already ready-made, here's the code, and when the problem is actually required domain expert that we don't have in QSL Lab, so we pass it around to the other startup or national lab we are working with. So it's a bit of helping, if you wish. We are like a first step. Have a chat with us, feel free, get access to the expert. We are 30 plus researchers in the lab. And then this would allow us to identify this pathfinding journey, hopefully.
How are you thinking today about quantum-inspired algorithms? Because, some companies have started with quantum computing, then they said computers are not good enough. We'll go back to quantum-inspired, which are essentially running on classical computers. Do you see that as just an improvement in classical computer science, or do you see that as part of the QSL or something that can truly advance quantum science?
Well, I would say this is like, we are scientists and we are remaining scientists. So that's another mission of QSL. When you're a researcher, bring it out. We usually don't even know what is the problem. We just come up with a random solution and we want to do it the other way around. So for me, the reason that again, the only novel thing in my own thinking for the lab is that, okay, let's just start from use case. And we don't know what is this use case. Let's just start that, I want to have a better synthetic data. I want to have a more secure differential privacy. I want to have more optimized bed allocation, etc. And then when you start so far away from the pain point, it's very natural at some point you don't have a quantum solution that fits to it. It's very natural that in this path of going forward, sometimes a classical problem, an optimization problem might be useful. And I'm pretty sure everybody in different company already see that, most of the time, maybe some of these R&D team are not even aware of the best classical solution. So if our journey will show that, from these 100 use cases that we play around, maybe 90 of them have an ideal ready-made classical solution, why not? But there is also, there's two ways to interpret the classical inspired or quantum inspired algorithm. Is that natural? Like some of the work we did recently with our team, we didn't intend it to do, but we showed that a large family of the VQE variational circuit actually can be classically simulated. I'm happy about that because it's again is like, because of we trying to understand where is the advantage or where is not the advantage, which is a very key question for us. We come up with a new method of simulation of this quantum circuit, and many people are doing that. So in short, I don't have anything against it. My mission is not to come up with a new classical algorithm. I'm actually very much excited to see where the quantum advantage is coming from and how we can capture it. But on the way to capturing this thing, we're clarifying the pathway. We understand it's not here. And if for those we don't get the advantage, on top of this, we come up with a novel solution of classical, even better. But this is for me is like a clarification. It's not the target. It's a byproduct of this exploration.
Given your software background and now doing it in quantum, what do you think is the missing piece or the biggest pain in software development today? Is it an abstraction layer? Is it actually better control of the hardware? Is it how do you do a circuit with large number of qubits? What do you see as the next pain point that's coming to software developers?
I just to clarify, it's like I'm not really the world expert on software. And if you think of it, I'm a computer scientist in the sense that if you go to the traditional study of computer science, we have algorithm, complexity, formal method, programming language, compiler, optimization, etc. That we take all of these courses, so we have a bit of familiarity. I think for me, overall, the biggest pain point for our field in quantum is that we are trying to reinvent a lot of wheel. So is that, we know there is a large class of classical ICT, as we say it in UK, is already very much relevant when you look at the control, the calibration, optimization, programming language. So I think for us, we are reaching into that era that because these devices are emerging, because the application is emerging, so finally we should be able to knock the door of our classical colleagues, say that, okay, as we did, 20 years ago, 30 years ago, the first computer scientists who were very much involved with quantum was algorithm complexity. We immediately find a common language and we could compare complexity classes in quantum or algorithm design. But the rest of the field of computer science, take it anything from verification, testing, formal method, optimization, and we are not really tapping in that space. So I think maybe the pain point is, again, the language barrier. Somehow, a subclass of track A of CS of the people who managed to overcome that barrier, but it's been a long time in the University of Edinburgh. School of Informatics is one of the largest in Europe, with the 1,000 plus staff, and they are all excited. The more they hear about quantum, they become more excited. And I feel like I wish all of my colleagues would understand quantum just like this, or at least be involved, because they have the solution to a lot of problems that we're trying to solve them. So we don't need to reinvent all of them from scratch. So it's the translation to existing knowledge.
As we get closer to the end of our conversation today, I wanted to ask you, I was looking at your background preparing for this call, and I saw that you did a lot of work on blind quantum computing. What is blind quantum computing and why is that important?
Thank you for asking that question. Most of the talk is just so this is one of the protocol that I co-invented with two of my colleagues, Joe Fitzsimon and Anne Broadman, back in 2009. And it's an example of those pathfinding that, we were working a lot on measure-based quantum computing, which is a different model of quantum computing that the classical and quantum separated. And we will be all exploring how could we exploit this thing. And before we realized that actually we invented this model for the secure cloud computing. So in future, right now, that when you look at all the quantum computing services are provided via cloud, we will ask the question about the security of this thing. You're very likely that when we seriously get involved in trying to connect to any of this cloud provider, we don't want our algorithm to be known, we don't want our data to be known, and et cetera, et cetera. This is a problem that exists classically, and fully homomorphic encryption is trying to solve it. So we come up with the solution for the quantum, which provides you information security for delegating your computation to the remote server while keeping all of your information and data intact. I think for me it's very important because it's almost like a tools for using quantum, because we believe for currently the model of the quantum, it will be this sort of giant beast that is sitting somewhere like in data center. So, and the privacy of the data in whatever application domain we go is become very crucial. So Blind QC, which is also the target of my startup, Very Cloud, is really providing that next level of trust so we can scale up. And on top of this Blind QC, we are able to provide integrity or verification of quantum computing. So to me, it's like, if we're serious to make quantum computing as a service, then the question of integrity and privacy can be provided with this framework of Blind QC, which also connecting quantum communication and quantum computing. So they're no longer separate fields. You need to have quantum communication on the client side to be able to exploit quantum computing on the server side. So that's blind quantum computing.
Thank you for that. QSL is new, and I'm wondering, professionally speaking, what keeps you up at night? What are you worried about the QSL, if anything?
Oh, it's like, it's already start worrying, because we're changing the direction. See, as a researcher, we sit down, we discover new things, and then we push it to the outside world. And that's something that I have been doing for the entire of my career, and leading all my team to let's explore whatever that it comes and then pushing it. And now I'm trying to change the gear. I'm trying to say that we know a lot of tools. We know verification, we know testing, we know algorithm design, we know abstraction. We know all of this thing, and I brought a lot of people together. But we want to do the game the other way around, bringing outside question and translate it. So I think till I see few example of this full process is really working, and I figure out the machinery that it's not ad hoc, but really there is a common journey that whether the problem is on accuracy or privacy or different sector, whether it's a fintech or I don't know, quantum chemistry, at the end of the day, this user journey is working, and I can bring this different expertise, as I was mentioning earlier, that they can talk together and we work together rather than just coming up with the next big breakthrough. That keeps me I'm even excited and worried because it's a new way. It's a new way of dealing with the problem, but it's also scary. So we'll see. Ask me in 6 months' time, and we'll see how far we made it.
I'd be happy to. And so my last question, hypothetical. If you could have dinner with one of the quantum greats, dead or alive, who would that person be?
Oh la la, okay. Dead or alive, a quantum person. It's going to be John Bell, you know. It's like the quality is just so amazing. Although we think we know everything about it, but the fact that as a mathematician he went and it really set up that framework, it's going to be amazing dinner just to chit-chatting. And there's plenty of other people alive, but I know I can have dinner with them anyway, so I go for him.
Excellent. Well, Elham, thank you so much for joining me today.
Thank you very much for having me. That was a great pleasure.